Originally defined by Wagner, the Auger parameter was calculated as follows. The Auger parameter was equal to the kinetic energy of the transition of the Auger peak minus the kinetic energy of the core photoelectron. However, this form of the equation allowed for negative values of alpha. The Auger parameter was then modified by the addition of the photon energy to alpha, and this modified Auger parameter, alpha prime, is independent of the X-ray energy used. So it's calculated as the kinetic energy of the transition of the Auger electrons plus the binding energy of the core photoelectron. It has the benefit of canceling out charging effects, and we now just, this is what's used now. So it's now not just, they don't call it the modified Auger parameter, it's now just the Auger parameter. So what use is the Auger parameter? Well, if we look at the photoelectron values for the cadmium 3D 5/2 peak, you can see that most of these values overlap to some degree, and there's actually a total separation of only about 1.7 eV, with large clusters of energies around 405 to 406 eV. So speciation becomes quite difficult using just the 3D 5/2 peak. Whereas if we look at the Auger parameter, we now have a total range of separation of 4.4 eV, and we get clear separation between things like cadmium oxide and cadmium hydroxide, which may be of interest. So let's go ahead and calculate an Auger parameter. This is for a sputtered cleaned cadmium metal sample. So if we go to the cadmium 3D 5/2 peak, we get a binding energy of 405.05 for that. And then all we do is we'll go to the Auger peak. We're going to click on kinetic energy because we want to use the kinetic energy. And we're going to take the kinetic energy of the maximum of the M4, N45, N45 peak. This peak over here is the M5, N45, N45 peak. Although it's a stronger peak, it's generally not as well resolved. There can be a broader peak maximum for some of the species, so that's why we tend to use this peak for this. So if we add those two together, 383.90, we get a total of 788.95 eV. So that's our Auger parameter. And if we compare this value to the literature values, we see we're well within the range for cadmium metal. We can look at another example of the calculation of the Auger parameter. This is a zinc oxide. So if we go to the zinc 2p3/2 peak, we have a binding energy of 1021.03. And if we go to the Auger peak, click on the kinetic energy, and really we just want to get the peak maximum. So we can either curve fit the peak and pick the energy of the peak that's there, or we can actually click on the spectrum and get the binding energy. So 988.99, or what we have over here, 988.98. Add those two together, we get 2010.0 eV. And if we compare that to our values of the Auger parameter for the between zinc metal and zinc oxide, clearly it falls within the range for the zinc oxide. So it's as simple as that.